Welcome to a J5 Robots Arduino tutorial. In this tutorial, I will show you the basics of using the Arduino platform. Before we get started, there's a few things I would like to point out about the Arduino platform. The Arduino platform is fun and easy to use. It is very versatile as there's many shields and attachments that can piggyback right on top of the board, making no wire connections necessary to complete the build that you want to do. There are many of these out there, so check them out. Probably have one that'll help you out in your build and make it a little easier on you. The Arduino also comes in various shapes and sizes, so you can check out. There's some Pro ones out there for more advanced users. The Arduino Uno is very good for the basic users. They are also available with various memory limits, so make sure you check those out to make sure you have enough room to support the projects you're going to do. And the hardware I'll be using today is the Arduino, which has power circuits here on the bottom, as well as your analog inputs over here and your digital outputs along the top. Arduino also comes in many packages, so you may find Arduinos is from as little as a stamp to the size of a credit card, and slightly larger. And then once you get the shields piggybacked on top of it, you can get a nice little brick going. There are many expansion kits out there which include other parts that you can get. Right here we have a thumb knob, so you can push and turn, and it has these connections right here on the front which allow you to easily connect an interface here, and they just plug right in to the shields that are available here. And then you can use this assembly, which has pins on the back to connect and route directly into and these piggyback for easy, quick connections, so you can assemble and disassemble big projects really quick. So each one of these are already mapped out, and you can get the breakdown of this Arduino output board. And there is also the Arduino Studio thumb knob. The Arduino Studio had a small speaker, a piezo speaker. There's signal, VCC, wire connection. There's some variable resistors that you can use. There's a push button. There's some LEDs that you can hook up so that they'll be easily interfaced directly to, as well as other things like ping range detection. With the ping range detection, you can determine distances, how far, how close you are to something else. So as you can see, these piggybacks can be very helpful. This piggyback is available from Arduino Studios. And I also have another piggyback here. This one's from Grove. It has ports that you can directly connect into with cables specifically suited for them. So you put these cables in, and then they could provide some of there's a circuit board interface. It plugs in exactly the same. There's a tilt sensor. So if you put it on a level surface, you can tell when a surface starts to tilt. Another shield out there is the basic shield from Grove. And with the Grove shield, you can plug in with a slightly different connector. And it's got 4 wires that come across and interface with various devices, such as this temperature sensor. These shields also come with LCDs You can also attach hobby servos, or maybe you need to connect to a relay. Either way, one of these shields should be able to do the job for you. But for this video, we're going to be using this Arduino as a standalone part. So to get started, we just got to install some software back here. So we will move over to the screen and pull up our web browser. So I want to go to arduino.ccc, and this will bring up Arduino's homepage, where you can see all the happenings of what's going on with Arduino and and the new advancements around Arduino, what people have been making with Arduino and other parts. Feel free to check that out in your leisure. But right now we want to go to download. And we just select the Arduino IDE and Arduino 1.0.5. And we will just select the Windows installer version. And now we just wait for our download to finish. But while that is downloading for us, I can show you Arduino, which we are using today for our hardware. And this is a blown up picture of the Arduino up close. So you can see the various power pins available here, including your grounds available here and the digital ground here. Your voltage in, as well as your output voltages you can supply for light duty work. There's your analog pins. And your digital pins. Pins 0 and 1 are wired into your transmit and receive. So you have to watch what you do when you're using those pins. 11, 10, and 9 are available for pulse width modulation. You have your reset between manual reset and automatic reset. Your 3.3 volts or 5 volts being the VCC. And here is your voltage input. And if you scroll down, you can see some more features and specifications of the Arduino board. And again, feel free to look about these at your leisure. This is the arduinostudio.com wiki page. And now with our download complete, we can simply click to run, select run, and we will agree to accept a public license for free software. And we want to install everything. Alright, now our installation is complete, so we can close this. It also might be helpful to note that you can install the software onto a USB and then run it from the USB. So this way you can take everything with you, save your files on the USB, and just load your software from anywhere you are. This helped me out a lot in college with going from computer to computer, not knowing what computer you are. Some computers have a different software version on it, and that may conflict with your program. So you'll want to check for that. So installing on an external USB can allow you to move from station to station and just boot to the IDE directly from the USB device. So now that our software is installed, we can simply click to open the software. And this is your first sketch. So it starts sketch underscore and a date. We'll need to first hook up our Arduino to our computer. So we'll just have to connect these together, and we'll see the lights already start flashing. And we have a power light that's on. And here our reset switch is located on the side. So you see the reset, the red light comes on. Some other Arduino boards actually have the reset button located somewhere in this area for this one. And we're running a basic script here. The basic script that comes on the Arduino boards when you first get them is a blink script. So you're just going to have a single blinking light. This is pin 13 that blinks, and it's already wired in with an LED that is active whenever the port is activated. We can check this and see this. I have a simple wired up here to an LED and a resistor. We can take this LED resistor, place them in the ground and pin 13. And again, you can see that the LED blinks. So, simple process. It's just on basic program that's on there. We'll have a look at this program now on the computer. So our basic sketch is for blink, and we can open this, and again this file is on the computer. It is not on the hardware itself. Once you are not able to actually read files back from the hardware. So this would be on the computer. This file comes as an example with the Arduino IDE, so everyone should have it available. You'll find these in the Arduino folder. Examples, basic, blink. So we can open our blink, and it opens a new window, so we can get rid of that one. We can see the short bit of code that makes this program work. So we define our variables, LED, pin 13. So we set up our routine, what's going to happen. We change our pin mode, turning LED, which we create up here, into an output. And then we're just going to create a loop down below that does a write LED, turns the LED high, which makes the LED become activated. Then delay for 1 second. So this is 1000 milliseconds. Then you want a digital write to LED, a low signal, and this will turn LED off, making the voltage low, and wait for another second, or 1000 milliseconds. And this just loops over and over and over again, repeating the same process. And that's all we're seeing happen here. We can change the time by changing these variables. 1000 here, we can change them to 2000, make it twice as, stay on twice as long, stay off twice as long, and break them in half, faster, slower. I think you get the point. So we'll start by first verifying, and this will compile our sketch and make sure that there are no errors in our sketch. And once it's done, it will say done compiling. Binary sketch tell you how big your program is and how much space is available. We now want to set up our output to our serial port. So we'll check the serial port is appropriate. In my case, it's COM13. And we will go to board, and I need to choose the Arduino 18 Mega 328. And then we will just upload. So it compiles the sketch one last time. And now with it uploaded, it continues to blink. So this is the basic program that you're going to start with on your Arduino. Okay, I showed you how the blink program works. Now I'm going to show you how to modify and save the file. So one thing we can modify in here is we can change the amount of time that the light blinks between on and off. So we're going to change the time delay in here to 500. So it'll be on for 500 and it'll be low for 500. I'm going to expand and see the notes here. So the high would be activated and the low would be deactivated. So now we'll verify that this file will compile. Once our file has compiled, we can then save it. So we'll save as, because we don't want to write over the current one. We can just go up one, and in the basics folder, I'm currently in the Arduino folder under examples, and I stored some of these under basic. And we can just make a new folder for this program. And we'll call this blink underscore half. Blink underscore half. And then we also call this blink underscore half. Then we save it. So now we have blink underscore half, and now we will upload this program to Arduino. Once it's done uploading, we can then see our program work. So now we can see the flashing, and we see it's flashing twice as fast as it was before. Simple enough program. And then we'll move on to show you a LDR program and circuit. So for this one, we'll just have a little setup to do, and then we'll load the file. So first we want to bring in our circuit. And for this one, the black wire connects to the ground. The red wire connects to the 5 volts pin. And the white one that I will plug in here connects to pin 0. And that connects to the break between the LDR, which is a light dependent resistor. So with this light dependent resistor and this other resistor, it's going to vary the resistance based on how much the light sensor is picking up. So with the LDR is a light dependent resistor, will vary its voltage drop based on the light received at the terminal here. And so we'll load this program. So we will file open, and I already have this file created as LDR. So we open the LDR file, and we can close the blank. And we can see the file here is not too much different than what we had before, but now we add in the sensor pin on pin 0. So we're sensing LD pin is still an output. And now we're going to take the rate and make it variable dependent on the analog read of sensor pin. So we're going to get a reading in here, and then we're going to add that to the delay. The turning on and turning off work the same. The rate is now controlled by a variable integer that is the sensor pin's reading. So we will upload this file, and we'll do its compile beforehand. And we can see now that it's starting to transmit data. And now we'll just tap our reset, make sure it starts fine. And now if we change the light over, we see it blinks faster and then slower. Nice little project. So we can vary this a little bit more. Just other variation is just on the program itself. We can map the analog input coming in from sensor pin and make it variable within a range that we want. And I will show you that with this other file. We will open my file LDR with a map. It says a mapped rate. So we will open, and I can put the two next to each other to show you there's not too much difference. There's no difference between these two. A few notes. We add some new integers up here, the min duration, max duration. So this will be the time it waits between the blinks, so they will range from 100 to 1,000. And with the analog read that we had before, now we take that rate and we map it. It's a nice little function they put here in Arduino, works great, I've used it many times, where we're going to take the rate between 200 and 800 to the minimum duration and maximum duration. And then the same here, we're inputting a rate in our variable delay. Then we see what the output comes to. So we will now upload this file and see how it changes the functionality of this circuit. Now we're loading and we're out. Okay, so we're blinking. Now if we change the light, you see it blinks faster. Give it light again. Slows down. Blinks faster. Slows down. So simple. There's two ways of doing this. The mapping makes it a little more, you get a little more control of your variation, and you can set your limits so you don't end up overpacing if some condition should occur that would allow it. So this is a great way to protect your circuits and make sure you don't put too much in or to provide limitations. Expand on this program a little bit more. I have another program in here for a serial. So now we can view what that, in this case we're going to open it up, and here's the code that we're currently running and the new code. So we're going to add a little bit to this code. We've got nothing that changes except for we have to set up our serial. So we set up our serial communications here, and we go into the loop again, and we see not much changes until we get to here where we send that to the monitor. So we're going to print rate to serial monitor, and the LED pin, nothing has changed there. So on this one, it should, when the rate changes, apply the rate change, let us know on the monitor what the change is, and also change the blink. So we'll upload this program and see how it goes. Okay, our upload is now complete. So we will check it out. So we just need to open our serial monitor. So we have a button right here on our Arduino window to load the monitor. And we see COM13 and we can see what the readings are. So as I move my finger over, we see those numbers get smaller and quicker. Remove my finger, the numbers become large again. Neat little trick, just have to change a little bit of code, it's great use. So if you need to read from an output, maybe you set up an external sensor, this is kind of the idea of what you're going to be looking at. So now I'll close our serial port. Okay, so we're all done here, and I've got one more program to go over. So I will open we'll add some audio to the circuit that we already have. And in order to do that, there's a small change in hardware as well as a small change and the software. So we're going to start by adding ourselves a potentiometer in here. We are going to then connect to that potentiometer a speaker. So we'll take the speaker output and we need a ground. And off our variable, we're taking our speaker sound off of pin 9. So I can go here to pin 9. And then place this in our circuit off our tap. So we will, with everything set up, we will upload our program. And we see it's uploading, and our upload is complete. We already have some sound here, it appears. Okay, and now if we block this, so now it's just changing sound. Pretty neat. Can get pretty annoying. Volume, to turn it down. Well, that is all I've got to show you right now. My name is Jonathan Veenstra, and thank you for watching Arduino tutorial of how to get started with Arduino. Check back with us soon for other neat projects. To find programs like this, as well as other easy, simple how-tos, check out the Arduino Cookbook. This is a great book, help you get around Arduino, get you started very quick.